Hello. Hello. Chetan, can you listen? Ganesh, can you listen? Good morning. Shall I start? Yes. Say, last class we discussed about the transducer. The transducer is used for transducing the input coming from the first stage, and then it is amplified and it is sent to the digital output or analytic output. So that's the one electronic transducer. In the same way, the mechanical transducer, that is a dial indicator, that's the pure 100% mechanical transducer. And next, electrical transducer, that is a linear variable differential transformer, where the movement of the core is the main function of the LVDT. So that is considered as the electrical transducer. Next, come to the point, the generalized description of a measuring system. This is very much essential for all the type of measurement, whether it may be pressure, temperature, voltage, or electrical current. The 5 stages, say starting from A to E, this is a very, very important and very, very important. That is the generalized description of a measuring system. Here, the primary sensing element, which receives the input and which amplifies and fed back to and fed to the second stage, that is the variable conversion element. There, that input, that the output coming from the primary sensing element, which is considered as input to this variable conversion element. Here, that input is converted into analogous signal. That analogous signal is processed and amplified or filtered depending upon the input required to the second stage. Here, in the variable manipulation element, whichever the output coming from the variable conversion element, it is considered as input to the variable manipulation element. That is, the analogous signal is converted into voltage signal here. That voltage signal is amplified, rectified, and filtered, and again which is sent back to and again fed to the data transmission element. So where the data transmission element, the function of the data transmission, the name itself indicates that whichever the voltage signal is as it is fed to the presentation unit. Or sometimes what will happen, then in the data transmission element, the voltage signal is converted into digital signal. That digital signal is fed to the data presentation element. that data presentation element gives the result of the measurement. So in case of pressure, that the pressure is in bar or kg per millimeter square. Suppose that is the weight or unknown mass, that is in grams or kgs. Suppose if it is stress, then it is load by area, that is kg per millimeter square. So like that, whichever the output is coming from the starting point A to E. These 5 media are very, very important for any type of measurement. Next, come to the point. Next, come to the point. And class is in Amal Kalman. That is, say, in case of any type of measurement. So for example, consider the measurement of strain using strain indicator. So you can use the V-stone bridge for the measurement of strain. With respect to generalized description of measuring system, you see that how the deformation takes place in the component. So due to the deformation, the strain induced in the component. Okay, first, the measured medium, that is the strain gauges. Say in the later classes, you study the metallic electrical resistance strain gauges. There you have the wire grid. If you apply the load on the strain gauge, there will be change in the resistance. Change in the resistance. The same type of strain gauges are used in electronic weighing machine. Also, for the measurement of axial strain or measurement of bending strain or measurement of torsional strain, all the three you have in strain measurement. So for example, in bending, calculation of bending strain, that is nothing but bending stress, calculation of bending stress. All of you know that V-stone bridge, where you have 4 resistances, R1, R2, R3 and R4. So in case of measuring bending strain on the cantilever beam, see, you have to study the bending strain in the later classes. So for measurement of strain, you can use V-stone bridge for the measurement of bending strain. So next, come to the point. How do you use this generalized description of measuring system for measurement of bending strain? For that, first consider the measured medium is the bending strain. The measured quantity is, the quantity means there is no unit for strain because the ratio of the initial dimension to the final dimension. For that reason, the strain doesn't have any units, that is measured quantity. Next, come to the point. The cantilever beam, apply the load on the cantilever beam. The one end of the cantilever beam is fixed, other end is open. In the other end, apply the load on the cantilever beam. First thing, so on the cantilever beam, you can fix 2 strain gauges or you can fix 4 strain gauges. Complete a circuit by using V-stone bridge. Complete the circuit V-stone bridge and fix the strain gauges diametrically opposite on the member. First, connect all connect, complete the circuit by using Wheatstone bridge. Here you have to measure the voltage coming from the circuit. You have to measure the voltage coming from the circuit. Before starting this experiment, what you have to do is bring the strain indicator to read zero or null balance. Bring the strain indicator to read null balance or read zero. Then apply the load on the cantilever beam. Apply the load on the cantilever beam. The beam contains the 4 strain gauges. So the 4 strain gauges, the function of the metallic electrical resistance strain gauge is to, whenever you apply the load on the strain gauge, there will be change in the resistance. There will be change in the resistance. As you apply the load on the cantilever beam, that exerts the force on the strain gauges, that is the primary sensing element. That is nothing but primary sensing element. After this, there will be change in the resistance. Change in the resistance of the strain gauges, that is converted into analogous signal. After applying the load on the cantilever beam, the beam deflects. Due to the deflection of the beam, there will be change in the resistance of the strain gauges. Due to the change in the resistance of the strain gauges, that is measured in terms of millivolts. That millivolt is converted into analogous signal. Remember, the change in the resistance that is measured in millivolts in the Wheatstone bridge, that is converted into analogous signal in the primary sensing stage. That is the change in the resistance. That analogous signal is fed to the variable conversion element. Here you have one more amplifier. Here you have one more amplifier that amplifies the signal which is coming from the primary sensing element, or the signal coming from the sensing element is filtered, amplified, rectified in the variable conversion element. That analogous signal is converted into the voltage signal. The variable conversion element which converts the analogous signal into the voltage signal. That voltage signal is fed to the third stage of the generalized description of a measuring system, variable manipulation element. The name itself indicates variable manipulation. That is nothing but the voltage is converted into the digital signal. The voltage signal is converted into digital signal. That digital signal which is coming from the variable manipulation element, which is fed to the data transmission element. Here the data transmission element, the function of the data transmission element is to transmit whichever the amplified signal, that is in the digital signal, which is fed to the data presentation element, where the data presentation, the name itself indicates the data presentation, that is nothing but digital strain indicator. Digital strain indicator which receives the signal which receives the signal from the dot transmission element that is converted into digital output. That is converted into digital output. That is in strain indicator. You can see the strain units. Strain, that is applying the load on the cantilever beam. Due to that load, the force exerts on the beam. The beam contains the 4 strain gauges. Due to the load, there will be change in the resistance. That change in the resistance can be measured in terms of millivolts. Millivolts. That millivolts can be converted into analogous signal in the primary sensing element. That primary sensing element that converts the millivolts coming from the change in the resistance of the strain gauges due to the application of the load on the cantilever beam. That the signal, whichever the millivolts output coming from the strain gauges, that is from the V-stone pit, it is converted into voltage signal. Voltage signal. That voltage signal is converted into analogous signal. Say in the variable conversion element, voltage signal is converted into analogous signal. That analogous signal is converted into again voltage signal. That voltage signal is fed to the variable manipulation element, where this voltage signal is converted into digital signal. Digital signal. And the digital signal, whichever the digital signal is coming here, that is amplified, rectified, filtered in the data transmission element and converted into the input required by the data presentation element. In this case, measurement of strain, the data presentation element is the strain indicator. Strain indicator. So in this strain indicator, you can measure the bending strain on the cantilever beam. By the application of the load on the cantilever beam, there will be change in the strain due to the application of the load on the cantilever beam. This is one method where you can measure the strain using bending strain using strain indicator. So last class we discussed about the digital weighing machine or electronic weighing machine, where generalized description of a measuring system can be applied. The same thing today we discussed about the generalized description of a measuring system for measurement of bending strain. So later in the class, you study the bending strain, axial strain, and the torsional strain. Next, come to the point. Once again, which are the portions covered till today? Once again, starting from the definition of calibration and fundamental method of measurement. So starting from, this is the last portion in the module 4. Again, so you have a little portion left in the module 4, that is intermediate to modifying system. What are the portions covered till today in this module? Just stage by stage, one by one. First, mechanical measurement. Mechanical measurement. So all of you please note down the portions for the test. Portions for the test. First, write down mechanical measurements. Mechanical measurement. So that is classified into, again, please write down mechanical measurement is classified into two. One is mechanics type of measurement. Number 2, power type of measurement. Power type of measurement. Power type of measurement. The first mechanics type of measurement is classified into 3 types. One is empirical method, second one rational method, and the experimental method. The empirical method is completely based on intuition. For that reason, this method of measurement makes this type of measurement sometimes which is proved to be wrong. So for that reason, nowadays in engineering or anywhere, we are not using empirical design method. Next, the rational method. So this rational method completely based on well-established scientific laws. Scientific laws. For example, if you want to calculate the velocity of a ball, so for that you use the equation v equal to u plus at. So that is nothing but the well-established scientific laws are present. From that you can calculate or you can do the measurement. Next year, the last one in case of mechanics type of measurement, the last one is the experimental method. Experimental method. Consider every field of engineering, whether it is mechanical engineering, electronic engineering, or any engineering, for measurement of design problem or the thermodynamics problem or kinematics of machinery problem or vibration problem or control engineering problem, all the problem in mechanical engineering, we are using the experimental method. We are using experimental method because this is a very, very accurate, precise one, and you have the precise result, sensitive result, precise result. This method of measurement is completely based on trial and error method. All of you remember the trial and error method. So this method is 100%, we cannot say 100%, but it is 99.99% correct. 99.99% correct. So for that reason, in all the engineering problems, we use the experimental method of measurement. Next come to the type of measurement, that is a power type of measurement. Here the power type of measurement. So for example, last few classes before we discussed about Raichur thermal power plant. The engineer or the operator will not go to the machine for changing or any controlling the function, controlling the system. So in the power plant, say the power plant is situated in somewhere and the control unit is situated 100 meters or 1000 meters away from the plant. So all the quantities like the speed of the turbine, the flow of coolant, temperature of the steam. Who is writing on the screen? Temperature of the screen, temperature of the steam, and all those things can be controlled away from the plant. That is the power type of measurement. Next come to the point, the fundamental method of measurement. That is, all of you write down fundamental method of measurement. So this fundamental method of measurement is classified into 2 types. One is a direct method, other one is indirect method. So indirect method, that's the direct measurement. I ask you to measure the length of the shaft. How do you measure? By using steel scale or tape, you measure the length of the shaft. The procedure followed for this measurement is the one end of the steel scale coincides with the one end of the shaft and the other end is coincides with the other end of the shaft. That will give you the measurement. That's in length, that's in millimeter or centimeter or in meters. In case of indirect method, so this is very, very important. In indirect method, there will be a transducer. There will be a transducer that transduces the input signal into the required form. You have already studied the measurement of taper by using mechanical transducer, that is a dial indicator. In dial indicator, dial rotates more than 1,000 times for small movement of 1 millimeter movement of the plunger. Just imagine the amplification of the dial by rack and pinion arrangement. So here, the movement of the plunger in upward direction, there will be 1,000 times rotation. That is the transducing the input into the 1,000 times by rack and pinion arrangement. So this is, you are not measuring directly of the movement of the plunger. There will be amplification of the movement of the plunger into the rotation of the dial in the dial indicator. This is in the direct method. There will be translation or transducing of the input, transducing of the input express. For that reason, it is called indirect method. Direct method means direct measurement, and you have the direct result, that is in length, that is in millimeter, centimeter, or in meters. Next come to the point, definition of the calibration. The calibration, so whichever the measuring instrument we use in metrology lab or the machine shop or in workshop, after continuous use of 5 years, 10 years, or 20 years, there will be damage or wear and tear and looseness in the mechanism and the friction in the mechanism, that will be more. Due to that, there will be error in the measurement. So if you have the result, wrong result, say for example, if you measure the diameter of the diameter of the shaft, if you have the diameter of the shaft is 10 millimeter, for example, diameter of the shaft is 10 millimeter. If you measure the diameter by using micrometer, instead of getting 10 millimeter, you may have 9.999 or you may have 10.01. That may be positive or negative error in the measurement. So that can be minimized, that can be avoided by using calibration method. So you can conduct static and dynamic calibration of measuring instrument. So calibration is very, very important for all the measurement. So please write down the question. Please write down the question. Explain briefly the following. Explain briefly the following. First one, calibration. First one, calibration. Second one, sensitivity. Second one, sensitivity. Third one, repeatability. Third one, repeatability. Fourth one, hysteresis. Fourth one, hysteresis. Fifth one, accuracy. Fifth one, accuracy. Sixth one, precision. Sixth one, precision. So among six, you have 400% guarantee in the examination. Mark it very, very important. In module 4, you have a question. Explain briefly the following. That's the calibration, precision, sensitivity, hysteresis. Like that, you have 4 in the examination. Next, come to the point. Write down what is transducer. What is transducer? Question mark. Question mark. What is transducer? Question mark. Next, write down. Define Define transfer efficiency. Define transfer efficiency. Define transfer efficiency. So this question carries 4 marks. This question carries 4 marks. Next, to write down. Explain briefly. Explain briefly with the block diagram. Explain briefly with block diagram. Primary and secondary transducers. Primary and secondary transducers. Next, write down the question. Explain with neat sketch. Explain with the neat sketch. Electronic transducer. Electronic transducer. Question mark. List the advantages. List the advantages and limitations. List the advantages and limitations. Write down next question. Write down a next question. Explain briefly. Explain briefly with block diagram. Explain briefly with block diagram. The generalized description of a measuring system. Generalized description of a measuring system. So for this question, write the explanation for primary sensing element, variable conversion element, variable manipulation element, data transmission element, and data presentation element. So write this block diagram and explain with your own sentence. Mark it very, very important. This time you have this question in the exam as well as in the test. Just go through the explanation here. You have an explanation here. A, B, C, D, E. Just go through the explanation and read it twice, thrice, and 4 times. And after that, write the explanation. So this much is enough for you. I will give you the complete notes to Ganesh, and Ganesh again will circulate the notes for you. So you have a test that's in between 15th to and between 11th to 15th of next month. You have all these portions in the test. So okay, now I make the unmute to all. Ganesh, can you listen?
Yes, sir.
Questions ella barkondra?
Sir.
Yes. So just questions in a list ಮಾಡಿಟ್ಕೊಂಡಿದೆ. Ganesh, I will tell you the time and the date of the test, and then prepare for the test. And today, questions covered till today, I will send you to you, and you can circulate the notes to your friends. Can you listen, Ganesh? Hello? Hello, Ganesh? Hello? Yes, Ganesh. Now I stop at this stage, and I'll continue in the next class.
Yes, sir.
Okay, thank you.